everyone, welcome to Fireshark. So let's start our new lesson, which is supporting and troubleshooting secure networks. And in this lesson, we are going to talk about the security appliances and troubleshoot services and security issues. So if you heard the name of firewalls, proxy servers, and there is another system which is intrusion detection prevention system. So we are going to cover these topics in this lesson. I mean, they help basically keep things private and secure. And even if you are not setting up these devices, it's important to know that how they work to keep computer networks safe from any kind of troublemakers. Okay. So the first topic is network segmentation enforcement. So I mean, for security purposes, we creating network. I mean, we divide the networks in different zones areas, kind of like creating zones, and it at layers, I mean at layers 2 and 3 we use a mix of virtual LANs and subnets in the form of network segment enforcement to make sure that this to make these zones, and each zone is like that its own space where all devices follow the same security rules. To control the traffic between these zones, we use a security device, which is called a firewall. So you can think of these zones as a special areas that protect different types of information in organization. Suppose for example, there might be a zone just for servers that store financial records, and another for servers used by the marketing team. So this separation helps to keep things safe, and if a problem like a virus starts in one zone, suppose it start in one area, then it's harder for it to move to other zones without going through the firewall first. Okay. So now when it comes to the host that face the internet directly, we call them internet facing host. And these hosts are in the parameter network zone. There is a parameter network zone, and these hosts are in this zone. And the idea is that traffic can't go through this zone directly. So basically this internet facing host act like a barrier, and the parameter network allows outside users to access certain kind of data like web servers, and without any kind of risking the security of the inner network. Okay. So if a host on different sides of the parameter need to communicate, a host within the parameter can act like a middleman or a proxy. For example, if a device in the inner network wants to connect a web server on the internet, a proxy in the parameter checks the request, and if it's safe, the proxy sends the request to the destination. And external hosts don't know what's behind the parameter, so that's why it's keep the things secure. So servers that provide services accessible from the outside, like web servers or email servers, are placed in this parameter network, and these servers are not fully trusted by the inner network because they could be targeted from the internet, right? We call them bastion hosts, and it's like having a special guard at the entrance to make sure everything coming in or going out safe. Now there is another topic which is screen subnets. So when we setting up a parameter network, there are two main security configurations needed. One for external side and another for the internal side. So one way to do this is by using a setup called a screen subnet, and which involves having two firewalls on either end of the parameter network. So the first firewall, often called the edge firewall or screening firewall, controls and limits traffic on the external side, and basically allowing only approved traffic to reach the devices in the parameter zone. So on the other hand, the second firewall, known as the internal firewall, or we called also choke firewall, manages the communication between the devices and in the parameter, and those in the local area network. I mean in the LAN. So the term choke point refers to the deliberately narrow gateway that makes it easier to control access to the and monitor activities. So in the past, this configuration was often called a demilitarized zone. I mean, but now it's more commonly referred as a screened subnet. So another way to establish a parameter network is by using a single router on firewall. devices with the three network interfaces. And this setup is known as triple homed, and each interface serves a different purpose. One connects to the public side, another connects to the parameters subnet, and third one is connects to the LAN. The rules set up for routing and filtering determine that what kind of communication is allowed between these interfaces, and this achieves a similar configuration to screen subnets and providing a secure separation between the external and internal parts of the network. So this is the part of the screen subnets. Now let's understand the uses of firewall and their types. How many types of firewalls are. So firewalls play a very crucial role in network security by filtering traffic based on the predefined rules. And the primary purpose to allow, this firewall is to allow or block data packets according to these rules. And these are various types of firewalls designed for different purposes. One way to classify firewalls is based on the scope of protection. Some firewalls safeguard entire networks, inspecting all traffic passing through, while others focus on protecting individual hosts, inspecting only the traffic directed at the specific host. So, packet filtering firewalls are one of the earliest types. They work at the layer 3 of the OSI model and examining the headers of IP packet. So rules are set in the network access controls list and specifying actions by different types of packets. The actions can be allowed like permitting the packet or denying, blocking the packet, and optionally logging the event, that kind of thing. So these firewalls consider information such as source and destination IP addresses, protocol type, and port numbers for filtering the decisions. So packet filtering firewalls can control inbound and outbound. In ingress or egress or both types of traffic, and managing outbound traffic is a beneficial for blocking unauthorized applications and preventing malware. So, however, these firewalls are stateless, meaning they don't maintain every information about the connection between hosts. So each packet is analyzed independently, and which is efficient, but may leave them when vulnerable to certain attacks that spread across the multiple packets. So you can understand through a real world scenarios, like suppose your office has a mail room and that only accepts packages from recognized courier service, allowed protocols, and rejects those from the unknown sources, blocked protocols. So this is the similar to packet filtering in a network, and where specific types of traffic are allowed or denied based on their predefined rules. Okay. Now, to address these limitations, stateful inspection firewalls were developed, and the operating at layer 5, operating session layer of the OSI model. These firewalls keep track of the state of the connection between hosts, and information about each session is stored in dynamic state table. And when packet arrives, the firewall checks if it is if it belongs to an existing connection, or if not, then it applies packet filtering rules. Once a connection is established, the firewall basically allows subsequent traffic to pass without any continuous monitoring, conserving, and processing resources. Okay. So you can also understand, like suppose in the office, if a courier, a data packet delivers a package in the sense of connection request. It sends a connection request and is approved by the mailroom, approved by the firewall, and subsequent delivers from the same courier are allowed without rechecking the package every time. This reflects the stateful inspection process, and where the firewall keeps a record of established connection, allowing subsequent traffic from those connections to pass through more efficiently. So in both cases, the goal is to maintain the secure environment by allowing only authorized entities, while um, preventing unauthorized access or potential threats. So in summary, while packet filtering firewalls focus on individual packet characteristics, stateful inspection firewalls maintain a broader understanding of the connection state between the hosts, and enhancing the security efficiency. And let's understand the firewall selection, their placement. That so when you're picking a firewall for your network, think about whether it's a hardware device like a separate box or a software. So also consider where you want to put it in your network. Like you have to uh, recognize that scenario, that where you have to install that firewall. So there are different types of firewalls. Some are good for protecting a whole part of your network, while others are better for keeping one device safe. So the kind of you choose depends on how much data your network has to handle. So if the firewall can't keep up with the data, it might slow things down. So an appliances firewall is a hardware device that only does firewall stop, and it watches all the data going in and out of a specific part of the network. So another type is a router firewall. It's built into a router, and many home routers have a built-in, but they usually handle less data than the ones a big company might use. So some fancy switches can also help for filtering the data. So when you're choosing a firewall, think about whether it's a separate device or a part of a router. So make sure it can handle the amount of the data of your network deals with. Okay, I mean, if you are going to use in the enterprises, you need different firewalls, or if you are going to use on a network setup in your house or a SOHO networking. So as you know that in SOHO networking in router there is a inbuilt firewalls in that mm, device. Okay, now let's understand the proxy servers. So while a firewall primarily decides whether to block or allow packets, a proxy server goes a step further, and instead of just inspecting packets, it acts as a middleman for its clients and forwarding their requests and responses on their behalf. So this happens in a special zone called the parameter network. So in parameter network, this proxy server works. I mean, forward proxies. Think of forward proxy. I mean, there is a kind of proxy, forward proxy server as a traffic manager for specific types of communication. For instance, you might deploy a web proxy that allows client devices to connect to the website securely, and this proxy understands the applications it serves, like parsing and modifying HTTP and HTTPS commands. So some proxies are application specific and focusing on particular protocols, while others are versatile, handling and multiple protocols types like HTTP, FTP, and SMTP. So the advantage here is that the clients connect to the proxy for a web server. So within the parameter network, enabling traffic, better traffic management and security. Many web proxies also include caching, storing frequently requested web pages to spend the subsequent requests. So imagine the forward proxy as a gatekeeper at the entrance of the building instead of letting people directly enter. So, in contrast, a transparent proxy intercepts client traffic without requiring any client reconfiguration. It's like a security guard inside the building who keeps an eye on everyone without them even knowing. So, proxy server works like that. And there is another proxy which is reverse proxies. So you can consider the reverse proxy like it deals with specific inbound traffic, and especially useful when you want to keep certain servers like messaging and VoIP servers away from the direct exposure to the internet. Then you can use this reverse proxies. Instead of placing these servers in the parameter network, you deploy a reverse proxy, and this proxy listens for client requests from the internet and then communicates with the internal servers on the corporate network. So you can think of the reverse proxy as a receptionist who sits between the external world of the office building When someone from outside wants to reach a specific person inside the building, they communicate with the receptionist, who then forwards the message to the right person, and this way the internal servers are shielded from direct exposure to the external threats. So reverse proxies can also handle encryption and decryption and authentication issues for remote users connecting to the corporate servers. And common applications for reverse servers, proxy servers, include publishing web servers, messaging or conferencing applications, and enabling POP IMAP mail travel. So they act as a protective barrier, ensuring that internal systems are secure while still facilitating necessary external connections. Now let's understand the network address translation, which is also called a NAT. It's a clever solution designed to deal with the shortage of available IP addresses, and its main job is to translate between the private address used within a local network, like your home or office, and the public address used on the internet. And this translation service takes place on the devices at the edge of the network, like a router, proxy server, or a firewall. So it's important to note that while net itself doesn't provide a security, the security features of the router or firewalls also implemented on to ensure the safety of the network. So in a basic NAT setup, there is a simple one-to-one mapping between a private network address inside a local and a public addresses, and this is particularly useful when you want to support connections to host from the outside. For instance, you have a web server behind a firewall running NAT, and the firewalls translate the web server's IP address and making it accessible to external hosts. So importantly, these external hosts don't know that the actual IP address of the web server. So they communicate with it and through the through this translated address. So, however, having just one static mapping isn't practical in many situations. So, this is where the dynamic NAT comes in. And so, in dynamic NAT, the NAT devices has a pool of public IP addresses and basically used to facilitate both inbound and outbound connections between the private network and the internet. So the NAT service maintains a table of mapping between the public and private addresses, and each new session creates a new entry in this table. And when the session ends, when the session ends or times out, the mapping is released for used by another host. So you can think of NAT in a real world scenario. Like think of your local network as a busting office, and each computer has a unique office extension number. So when someone from the outside, the internet, wants to talk a specific person like a computer, and inside the office they dial the main office number, which is a public address, and the receptionist, which is the NAT device, then forward the call to the correct extension, to the private address, and this way the internal extensions remain private and the outside world communicates with the office through a single public number. Now let's understand the port address translation, which is also called PAT. Is It's a basically extension of basic NAT, and designed to efficiently handle multiple simultaneous connections while using a limited number of available IP addresses. So in each situations where companies have only have been a single, assigned a single or a small block of public IP addresses by their internal service providers, so PAT becomes a valuable solution, and it's also known as network address port translation. Basically, it's NAT overloading or one to many NAT. Okay. So basically, how PAT works? It works by dynamically assigning each new connections to a unique ephemeral TCP or UDP port. And to illustrate, imagine two hosts, like let's call them, there is a host 10.0.0.101 and there is another 10.0.0.102, and initiating web connections at the same time. So the patch servers operating at the network's edge and creates two distinct port mapping for these requests, like 10.0.0.1 colon 61101 61102. So in its internal state table, it then replace the private IP addresses with the public IP addresses and forward these requests to the public internet. So now when responses come back from the internet, PAT performs a reverse mapping, and it uses the information stored in its state table to match the returning traffic to basically we can say appropriate internal hosts, and it replaced the public IP addresses and port numbers with original private IP addresses and ports, and forwarding the response packets to the correct internal hosts. So think of your local post office handling mail from various people in your neighborhood and who share the same post office box number, and each person has a unique key. External port number to access the mail in the shared box. So similarly, Pat assigned a unique port numbers to different connections, allowing multiple internal devices to share a single public IP addresses, much like sharing a post office box number. Okay, now let's understand the defense in depth. Means there is a smart approach to keep computer networks safe from the cyber threats, and instead of relying solely on a single protective layer at the network edge like firewalls and subnets, it involves spreading security measures throughout the entire network, and this helps ensure that the only every attempt to access the network is thoroughly checked and approved and monitored. So there is a NAC, which is network access control, is akin to a security checkpoint for devices trying to connect to the network. So there is a NAC, network access control. In networking, NAC is a kind of akin to a security checkpoint for devices trying to connect to the network. So when a device attempts to join, firstly, NAC authenticates it, ensuring it has the right credentials and meets security standards. Uh, so it's like a security guard checking IDs and the health certificates before allowing the entry. So there is also a called honeypots. So in networking, honeypots are like decoy systems designed to attract potential attackers, and these systems mimic the real assets and help security teams observe and understand the attacks methods, and it's comparable to setting up a dummy server to see how hackers might try to infiltrate the actual network. So it's like setting up a fake target to see how hackers behave. So by studying their tactics, you can better protect the real systems. So it's a bit like have leaving out a fake wallet to catch uh, a pickpocket. Okay, now separation of duties means involves dividing different responsibilities among different individuals to enhance security. For instance, one person might manage users access while other oversees system configuration. So this division prevents a single person from having too much control and reducing the risk of internal threats. It's like having a different team members responsible for specific aspects of network security. So this prevents one player from doing everything and reducing the chances of cheating or mistakes. It's like making sure everyone on the team has a specific job to keep the game fair and secure. So in the Asian's defense is in depth is networking employs strategies such as NAC for strict access control, honeypots for threat observation, and separation of duties for internal checks and the balances. So together these measures create a comprehensive and layered approach to the network security. Now there is a intrusion detection and prevention systems. It's like a digital security guard that constantly analyze network traffic or system logs in real time. So instead of using rules like firewall and IDs, uses signature patterns, each representing a non-type of malicious activity. So if it detects a pattern in the traffic, it raises an alert similar to how antivirus software flags potential threats. So the IDs needs to stay updated with the latest patterns to be effective, and may also use automated threat data like the list of malicious IP addresses. So the ID is positioned behind a firewall to catch suspicious traffic that the firewall may have missed. So adding an extra layer of security known as defense in depth, and it's a passive sensor means it doesn't actually interfere with the traffic and is not easily detectable by attackers. So on the other hand, an intrusion prevention systems IPS not only detects the threats but actively respond to them. For instance, it can end a it can end a session with an attacking host or block the attacker's IP addresses temporarily. So advanced IPs measures include adjusting bandwidth, applying complex firewall filters, or modifying suspicious packets to neutralize them. Okay, so IPS functionality is often integrated into firewall appliances and proxy servers, but it requires quick processing to prevent slowing down the network. So network IDs and IPS can work alongside host-based IDs and IPS, which run on individual system to monitor applications, files, and logs for any kind of suspicious activity. So, advanced IDs and IPS systems analyze data from multiple sensors to identify both, suspicious network traffic and unusual activities on individual systems. So, combining these methods provide a comprehensive approach to identify and responding to potential security threats. So, these are the main function of this IDs and intrusion detection systems. So that's it for today's session. In the next session, we are going to cover next topic. Thank you.